34, solve the system of linear equations using substitution method. If a solution exists, give it as an ordered pair, show all work. So we have 4x minus y equals 7, and negative 2x plus 5y is equal to 19. Substitution method means solve for one and then plug in to the other equation. In this case, I will be solving for y and plugging it into there. It's equal to 7. Subtract 4x from both sides. Divide by negative 1. Okay, now that I have that, plug it into here, so it'll be 2x plus 5 times negative 7 plus 4x equals 19. And now I'll solve for x. Combine like terms. Add 35 to both sides. And then divide by 18. X is equal to 3. Plug that back into this guy to get our ordered pair. Should give us y equals 5. So we should list it as an ordered pair, 3, 5. Solve the system of linear equations using the elimination/addition method. If a solution exists, give it as an ordered pair, show all work. So 9x minus 2y is equal to 4, and 2x plus 4y is equal to 7. So the first thing with the elimination method, we want the same magnitude in terms of one of them, but opposite signs. So the easiest one here would be to try and get this 2y and that 4y to be the same value. So I'm going to multiply that first equation by 2. So we're going to get 18x minus 4y is equal to 8. Now we can add those two equations together. And we're going to get 20x plus 0y is equal to 15. Or 20x is equal to 15. X is equal to 3/4. Now at this point we can use either equation to solve for the other one. I'm going to pick the second one, just looks easier. So plugging in the x to there. So we're going to get 3/2 plus 4y is equal to 7. 4y is equal to, come out to be 11/2. And then when we divide both sides by 4, we'll get 11/8. We are to give it as an ordered pair. So 3/4, 11/8. So the following system of linear equations, give your solution as an ordered pair, show all work. So we have 1/2 x plus y is equal to negative 2. X minus 2y is equal to 8. Or they didn't specify a method, we can use whichever method we want. I'm going to elect to use the elimination method. I'm going to multiply this first equation all by 2. So we're going to get x plus 2y is equal to negative 4. We can add those equations together. So we get 2x plus 0y is equal to 4, or 2x is equal to 4, x is equal to 2. Once we have that, we can plug it back into either equation. I'm going to plug it into that first equation. So 2 minus 2y is equal to 8. Negative 2y should equal 6. Y is negative 3. They did ask for this in an ordered pair, so that would be 2 comma negative 3. Use a system of linear equations to solve the following. How many liters of 40% acid solution and how many liters of a 10% solution should be mixed to obtain a 20 liter of 22% solution? Answer with a complete sentence, show all work. Okay, so we'll call the 40% X, and we'll call the 10% Y, or the volumes of them. And we know that that should equal 20 in total. And then we know it'll be 0.4x for the 40% times the amount of X plus 0.1y should equal 0.22 times 20. Okay, that means 0.4x plus 0.1y equal to 4.4. I'm going to multiply that everything by 10. 44. There we go. So now we have equation 1, equation 2. I'm going to multiply equation 1 by negative 1. Bring it down here. So negative x minus y is equal to negative 20. This sets it up perfectly for the elimination method. So we get 3x plus 0y is equal to 24, or 3x is equal to 24, x is equal to 8. Now we can use that original first equation, which gives us y is equal to 12. So then they did want this in the form of a sentence. So 8 liters of 40% solution should be added to 12 liters of 10% solution to get 20 liters of 22% solution. All right, use a linear system to solve the following. Sam and Ted make an ice cream sundae, each make an ice cream sundae. Sam gets 3 scoops of cherry ice cream and 1 scoop of mint chocolate chip for a total of 57 grams. Ted has 2 and 2 for a total of 62 grams. How many grams of fat does 1 scoop of each ice cream have? Answer in complete sentences. So I'm going to call my X the cherry. So 3x plus 1 mint, we'll call that y, is equal to 57. And then 2x plus 2y is equal to 62. This time I like to use a substitution method where we have this lone y here. So if we solve for y in that equation, we get 57 minus 3x. Plug that into the second equation. to 2x plus 114 minus 6x is equal to 62. Combine like terms. Subtract off the 114 from both sides. Which should give us negative 52. Divide both sides by 4. That'll get us to 13. Plug it back into either equation. We'll do 3 times 13 plus y is equal to 57. 39 plus y. That should be a 57. It's equal to 57. So that means y is equal to 18. So then answer in a full sentence. That means, a scoop of X was our cherry, has 13 grams of fat, and a scoop of the mint has 18 grams of fat. 39, solve the nonlinear system of this using substitution method. So I'll solve for my y first. So y is equal to 5 minus 2x. That means I can put into this one right here. So x squared plus 5 minus 2x squared is equal to 50. So that means we need to FOIL it out, which will give us 25 minus 10x plus 4x squared is equal to 50. Combine like terms. So we get 5x squared minus 20x plus 25 is equal to 50. Subtract 50 from both sides. Divide everything by 5. Then we should be able to factor that into x minus 5, x plus 1 still equal to 0. So that means our x values are going to be positive 5 and negative 1. Then we can plug both of those into there. So one of them will be y is equal to 5 minus 2 times 5, which is equal to negative 5. And then y is equal to 5 minus 2 times negative 1, which is equal to 7. So the order pairs will be 5. The one that corresponds with 5 is negative 5. And then negative 1, and that corresponds to a positive 7 in the y.
Okay, now looking at question 40, we're going to solve the nonlinear system. X squared plus y squared is equal to 17. And then x squared minus 2y squared is equal to negative 31. Right? So we're going to use the addition/elimination method. So we need to find a way to cancel out either our x squareds or our y squareds. There's two ways we can do this. We can either multiply our top one by 2, or we can multiply our bottom one by a negative. Multiply our top one by 2, we can cancel out our y squareds. And if we multiply our bottom one, we can cancel out our x squareds. So let's go ahead and cancel out our y squareds. So let's multiply our top one by 2. So we're going to have now 2x squared plus 2y squared is equal to 17 times 2, which should be 34. So now we want to use our addition and add them together. So when we do that, we're going to have 3x squared. Our y squared is going to cancel out. And then we're going to have 3 left over. So now what we're going to have to do is divide both sides by 3. So we have x squared is equal to 1. So we know that x, that means that x, we introduce a square root to both sides. That means we have to have plus or minus 1 for our x value, right? Now, since we have x, now we got to go back and find y. I'm going to use our initial equation of x squared plus y squared is equal to 17. Knowing that x squared is always going to be 1, we can say that 1 plus y squared is equal to 17. That means that y squared, we're going to subtract 1 on both sides. Y squared is equal to 16. Doing a square root of both sides, we know that y squared is going to be equal to plus or minus, y is going to be equal to plus or minus 4. So that means we have 4 solutions. We have 1 and 4, -1, 4, 1, -4, and then also 1, +4. And those are going to be our 4 solutions for this nonlinear system. Now looking at question 41, we want to solve the nonlinear system for xy plus 3y squared is equal to -9 over 2xy plus y squared is equal to -5. So we can do this one either by substitution or elimination. Doesn't really give us a specific way that they want us to. I see that we can, if we multiply our second equation by -2, we can cancel out an x and a y, and then we'll just have y's left. That might make our equation a little bit simpler on ourselves. So why don't we go ahead and do that? Multiply this one by -2. So we're going to go ahead and bring that first equation down, 4xy plus 3y squared is equal to -9. So now we have -4xy minus 2y squared is equal to, now we have a positive 10 here. Now when we add these together, our 4xy's go away, and then we're left with y squared, and then is equal to 1, right? So that means we take square root of both sides. That means we know that y is going to be equal to plus or minus 1. So now, going back into our equation, we're going to say, we're going to go back to 2xy. 2xy plus y squared is equal to -5. We're going to plug +1 in and -1. So when y is equal to -1, we're going to have 2x times -1 plus -1 squared is equal to -5. So now we have -2x plus 1 is equal to -5. So -2x is equal to -6 as we subtract 1 on both sides. Then to find what x is, we're going to divide both sides by -2. So that means that x is going to be equal to 3 when y is equal to -1. So now we can write that as 3, -1. And I'm going to erase all this so we can try when y is equal to 2. When y is equal to 1. So now when y is equal to 1, we're going to have 2 times x times 1 plus 1 squared is equal to -5. So that means we have 2x plus 1 is equal to -5. Subtract 1 on both sides. So we have 2x is equal to -6. Divide both sides by 2. So x is equal to -3 when y is equal to 1. So we can say -3, 1 is our other coordinate, our other solution. Okay, looking at the last question on the review, number 42. use a nonlinear system of equations to solve the following application. A rectangular window has a 15-yard diagonal and an area of 108 yards. Find the dimensions of the window. First, let's just draw the window out. I'm going to use a shape here. So here's our window. And then the diagonal is going to be like that with 15 yards. We have an area of 108 yards squared, right? And then find all the dimensions of the window. So we're going to find the length and the height. So one thing we can do is we know that the area, we can break this into two triangles, right? So we'll have a triangle with a 15-yard diagonal. Knowing that, we know that the area is also in half now too. So this new area, area 2 of the triangle, is going to be equal to 54 yards squared. And we know the area equation, area is equal to 1/2 base, just as call this base x and this height y, x, y, right? Then we also know we have that this is also a triangle, which means a Pythagorean theorem. So we're going to know that x squared plus y squared is going to be equal to our c of 15 squared. Right, so now we have two nonlinear systems, and now we can solve. I think I would prefer to solve this using substitution personally, since we're doing multiplication. So a squared, so I have to write this as 54 is equal to 1/2 xy. So I'm going to solve this one for x. So multiply 54 by 2, multiply both sides by 2, I guess, by 2. So we're going to have 108 is equal to x times y. Could have also just done the area of the whole rectangle. So let's solve for x. So x is going to be equal to 108 over y. So now we're going to plug this in to this equation here. So 108 over y squared plus y squared is equal to 15 squared, which we can say 15 squared is 225. Right? So now, simplify this. So 108 squared, it's going to leave that as 108 squared over y squared plus y squared is equal to 225. Right? So now I'm going to erase some of this just to give us some space and bring it back up. So now I'm going to bring this up. Okay, so now we want to solve for y squared. So one thing we're going to have to do is get rid of this y in our denominator. One way we can do that is multiplying everything by y squared. It's going to leave us with 108 squared plus y to the 4th, and then is equal to 225 y squared, right? So now from here, what we can do is get all the y's on one side. So y to the 4th, subtract 225 y squared on both sides, minus 225 y squared plus 108 squared is equal to 0. All right, one thing is here we're going to have to use a substitution to find out, put it in a quadratic form. We can use our Pythagorean theorem, our quadratic equation. So I'm going to say that u is equal to y squared. So we're going to have u squared minus 225u plus 108 squared is equal to 0. Right? So from here, what we're going to do is we're going to say that our u is equal to, use our quadratic equation, minus b plus or minus the square root of b squared minus 4ac all over 2a. So in our case here, we're going to have negative 225 plus or minus square root of negative 225 squared minus 4 times 1 times 108 squared, and then all over 2. Plug that into our calculator twice, and that's going to leave us with, oh, sorry, plugged it in wrong. So it's going to leave one u value equal to 81 and another u value equal to 144, right? So we know u is equal to y squared, so we're going to say y squared is equal to 81, y squared is equal to 144. So now we know that y squared is going to be, so y, we're going to take the square root of both sides. So we're working in real world problems. We don't need a negative value here, so we're just going to have y is equal to 9. Do the same thing over here. Y is equal to 12. So this also works for our length and our width. But just to check, we're going to go back to our equation of x squared plus y squared equals 15 squared. Try it with 9 to make sure we get 15 or 12 for y squared, or for x squared. So x squared is going to be equal to 15 squared minus 9 squared. So we know that x squared is equal to 15 squared minus 9 squared. X squared is equal to 144, which makes x equal to 12. So the answer is a complete sentence. So we know the window is 9 yards by 12 yards.